Hello students, this is a continuation of our previous video. Now the second part of the third property is we have to prove that alpha cut of A union B is equal to alpha cut of A union alpha cut of B. Now this can be proved in two steps where we will be proving that alpha cut of A union B is a subset of alpha cut of A union alpha cut of B. And then the second step we will be proving that alpha cut of A union alpha cut of B is a subset of alpha cut of A union B. So by this we will be proving that this is equal to this. So first let us prove that alpha cut of A union B is a subset of alpha cut of A union alpha cut of B, for which first we have to take an element in this set and we have to prove that that element also belongs to this full set. So let us do it now. So first let us choose X to be an element of alpha cut of A union B. This implies that A union B of X, A union B of is greater than or equal to alpha. So like this. So now by the definition of fuzzy union, A union B of X is equals to maximum of A of X comma B of X. So this can be written as maximum of A of X comma B of X is greater than or equal to alpha. Now if you see maximum of this and this, so we don't know which is maximum. Either A of X can be maximum or B of X can be maximum. So if A of X is maximum out of these two, then A of X will be greater than or equal to alpha. So A of X greater than or equal to alpha. If not, if A of X is not maximum but B of X is maximum, then B of X will be greater than or equal to alpha. But both cannot happen at the same time. So this or, so we should use the word or here. So or B of X is greater than or equal to alpha. So always remember, if it is or, then it comes under union. So A, if you have two sets, so A union B, A union B. So if X is an element of this, it implies that X is an element of A or X is an element of B. So whenever you have or, it will be union. So therefore, now here A of X is greater than or equal to alpha, and this implies that X is an element of alpha cut of A. And B of X greater than or equal to alpha implies that X is an element of alpha cut of B. So we have to bring down this or. So either X is an element of alpha cut of A or X is an element of alpha cut of B. So what I told you, or means union. So therefore X will be an element of alpha cut of A union alpha cut of B. So if it is either in this or in this, but when we take the union of these two sets, definitely X will be an element of that set. So this is how we have got it. So we started with an element of alpha cut of X an element of alpha cut of A union B, and we have proved that X is also an element of alpha cut of A union alpha cut of B, and hence we can say that alpha cut of A union B is a subset of. So this is a subset of alpha cut of A union alpha cut of B. Now next we have to prove the second step. So let's mark this as equation 1, and now we are proving the second step, that is we have to prove that alpha cut of A union alpha cut of B is a subset of alpha cut of A union B. So for that, first we consider an element from this set, and X is an element of alpha cut of A union alpha cut of B. I have already told you union means you have to write or. So X is an element of alpha cut of A or X is an element of alpha cut of B. So now if X is an element of alpha cut of A, then A of X will be greater than or equal to alpha. Similarly, here we will have B of X to be greater than or equal to alpha. This is by the definition of alpha cuts. Now, because these two are greater than or equal to alpha, we don't know which is maximum out of these two. But we can say that because both are greater than or equal to alpha, the maximum of these two will also be greater than or equal to alpha. So we have written this. And we know that maximum is A union B. So A union B of x is greater than or equal to alpha, and hence we have x to be an element of alpha cut of A union B. So we started with x an element of this set, and we have proved that it is also an element of this set, and therefore this set is a subset of this. So we shall mark this as equation 2. Now from equation 1 and equation 2 we can combine both, and we can write alpha cut of A union B is equal to alpha cut of A union alpha cut of B. So this is property 3 of the elementary properties of alpha cut. We have property 4 where it is same as property 3. The only difference is property 3 deals with alpha cuts and property 4 deals with strong alpha cut. So if you see that here, property 3 we have proved. So similarly we can prove property 4 by doing for strong alpha cut. In which case, instead of greater than or equal to, wherever we have greater than or equal to, we will have strictly greater than. Only that will be the difference in both the proof. That is in the proof of this as well as this. It is same as the proof of property 3. The only difference is we will be having strictly greater than symbol at these places. Wherever we have greater than or equal to, in all those places we should write only strictly greater than. So that will be the only change we will be making. Otherwise it is same as proving property 3 only. So I give it as an exercise. Kindly do it for yourself. So now let's move on to the last property. So the proof of the last property we will see. What does the last property say? Alpha cut of A complement is equal to 1 minus alpha strong cut of A complement. So we shall see the proof of this now. The property 5 states that alpha cut of A complement is equal to 1 minus alpha strong cut of A complement. Now this can be proved in two steps. In the first step we will be proving that this is a subset of this set. In the second step, the term on the right will be a subset to the term on the left. So we shall see the proof of the first one now. So we have to prove this now. So for this we shall first take an element x to be an element of alpha cut of A bar. Now we have to prove that this element x is also an element of 1 minus alpha strong cut of A complement. Now because x is an element of alpha cut of A complement, by the definition of alpha cut, A complement of x will be greater than or equal to alpha. So this A complement of x can be written as 1 minus A of x greater than or equal to alpha. So taking this 1 to the other side, we get negative A of x to be greater than or equal to alpha minus 1. Now we shall change the sign throughout. So when we change the sign, we get A of x. The inequality changes to be lesser than or equal to. Whenever we change the sign on both the sides, if we have an inequality greater than or equal to, it will change to lesser than or equal to. And here this will be negative alpha plus 1. And so this can be rewritten as A of x to be lesser than or equal to 1 minus alpha. So this implies that A of x is not greater than alpha. 1 minus alpha. So here we see that A of x is less than or equal to 1 minus alpha. So A of x can be either lesser or equal to 1 minus alpha, which means that it is strictly not greater than 1 minus alpha. If this is not greater than 1 minus alpha, we can say that x is not an element of 1 minus alpha strong cut of A. The reason is it is strictly greater than, not greater than 1 minus alpha. So from this we can say like this. So if this is not an element of 1 minus alpha strong alpha 1 minus alpha cut of A, then definitely it has to be an element of 1 minus alpha strong cut of A bar, that is its complement. So if this is not in 1 minus alpha strong 1 minus alpha cut of A, then it has to be an element of a strong 1 minus alpha cut of its complement A bar. So from this we can say that, so we started with an element from X, an element of alpha cut of A complement, and we have proved that it is also an element of 1 minus alpha cut, a strong cut of A complement, and so we have proved that this is a subset of this. So first proof is over. Now we shall prove the second step. Let us mark this as equation 1. Now second step we have to prove. So now we have to prove that 1 minus alpha strong cut of A bar is a subset of this. So let us take an element X to be an element of 1 minus alpha strong cut of A complement. So if this is an element of this, we can say that X is not an element of 1 minus alpha strong cut of A, because if it is an element of 1 minus alpha strong cut of A complement, then it cannot be in 1 minus alpha strong cut of A. So if it is not an element of this, then we can say that A of X. So A of X is strictly not greater than 1 minus alpha, and from this we can say that A of X is lesser than or equal to 1 minus alpha. Now bringing this 1 to the left hand side, we get negative 1 plus A of X to be lesser than or equal to negative alpha. Now changing the sign throughout, we will be getting this negative 1 becomes positive, this plus becomes minus, so A of X, and less than or equality becomes greater than or equal to, and this negative sign becomes positive, and so this is alpha. So this is 1 minus A of X is greater than or equal to alpha. But what is 1 minus A of X? A complement. So A complement of X is greater than or equal to alpha, and this implies that X is an element of alpha cut of A complement. And we started an element with in this set, and we have proved that it is also an element of alpha cut of A complement, and hence we are done with the second part of the proof, that is say a second step. So from 1 and 2 we observe that, so from 1 and 2 we observe that alpha cut of A complement is equal to 1 minus alpha strong cut of A complement. So we are done with the proof. So with this we are done with all the 5 properties, elementary properties of alpha cut. So hence this theorem has been proved in 3 videos as part 1, part 2 and part 3. Kindly find it in the playlist. Hope you have understood all the proof. Thank you.